All right, welcome everyone. I am JJ. Let's tackle an example problem. So we're just saying here, let's determine Ix for the object shown. We have our x-axis labeled, find the moment of inertia about that axis. Our first step is break it into pieces. There's a lot of ways we could do this. I've seen people do a big rectangle here, and then 1, 2, 3, 4 holes. That totally works for us. I would come in and do a rectangle on the top, and then and a triangle, and then 2 holes. It's 4 pieces instead of 5. It's kind of a toss-up. Either way is about the same amount of work. We're going to do it my way. So one rectangle here, one triangle. We're actually going to call that triangle shape 1. So that's 1. Our rectangle, let's call that shape 2. And then I have a semicircle and a quarter circle. So let's call my semicircle shape 3, and that quarter circle, shape 4. 4 pieces for me to come in and work with. I can totally get here. Also, my general equation, I'm going to have to use the parallel axis theorem for this. The parallel axis theorem is that my moment of inertia about any axis I want to take a look at, this is the x-axis for this problem, is going to be equal to my moment of inertia about the centroid of a piece plus the distance in between my any axis and the centroid squared times the area. So let's go ahead and start filling in those pieces in there. So for my first piece, I had a triangle. So I can say my moment of inertia, or actually, let's get one last piece written in here. If I'm looking for moment of inertia, I have 4 pieces. I can say my Ix overall is, well, 1 and 2 were positive shapes, so I'll add them in. Ix1 plus Ix2. 3 and 4 were negative. So minus Ix3 minus Ix4. So let's find each of those pieces and just sum everything up, and it'll get us through the entire problem. So shape 1, our triangle here, moment of inertia about the centroid of a triangle. Well, that's about the flat side, bh cubed over 36. So Ix1 is my base, 5, times the height, 9. 5 times 9 cubed divided by 36. Plus, what's my distance from the x-axis to the centroid of my individual piece? This moment of inertia about the centroid of our triangle. So plus, from x to that centroid would be 9 minus 9/3. So plus 9 minus 9/3, or 2/3 of 9, this is going to be 6. My distance, I square, and then multiply by the area. So times 1/2, our base was 5, and the height was 9. Or this is going to get me to 911.25. 911.25 inches to the 4th. That's my first piece. We're a quarter of the way done. So let's go on and get the second one. Ix2 should be, well, this one's a rectangle. So I'm coming to this one. I want Ix prime, my moment of inertia about the x-axis, is my moment of inertia about its centroid. So Ix prime, bh cubed over 12. My base here is 5 plus 13, the entire width. So 18 times my height is 10. 18 times 10 cubed over 12. Plus the distance between the x-axis and the centroid of my rectangle. Well, that would be 9 plus halfway into it, or just the radius in. So 9 plus 5 plus 9 plus 5, or 9 plus, I know the whole height is 10. 9 plus 10 divided by 2 gets me there as well. Either way, it's 14 squared times the area, times 10 by 18, times my base is 18, my height is 10. Or this gets me a much bigger moment of inertia, 36,780 inches to the 4th. That's my first two shapes. Those are both positive ones. Everything else from here, I need to subtract out. But I'll calculate it like it's positive. That I get both halves of my parallel axis theorem actually being subtracted. So Ix3, that's semicircle. I'm going to get, there's one tricky thing in here. I'm looking for my moment of inertia about the x-axis. If I look up to that, I notice my moment of inertia about the centroid. Right now, my axis is going perpendicular to the flat side of that centroid. If I come down to my table, my semicircle is oriented differently in here. So I have to be able to adjust my equation. I want not to just blindly take Ix prime. I need to adjust that. I want an axis going perpendicular to the flat side in here. Or I want to take here my Iy prime because it correlates to perpendicular to, or it correlates to, we look perpendicular to it. That is the y prime axis here. So pi r to the fourth over 8. So pi, my radius was 5 to the fourth over 8. Plus my distance from that centroidal x-axis, the middle of my semicircle, to the x-axis, well, that would be 5 plus 9, 14 squared. So plus 14 squared times the area, which would be 1/2 pi times the radius squared. Pi times 5 squared. Which is going to get me that for shape 3, my Ix, if it was positive, will be 7,942. 7,942.34 inches to the fourth. And then there's just one last shape to get. I need that quarter circle up at the very top of this. So I can say that my Ix4 should be, well, I want my moment of inertia about the x-axis is my moment of inertia about the centroidal x-axis plus the distance between those squared times our area, which that Ix bar should be, if we look at our picture, the x-axis that goes through the centroid is perpendicular to the flat side. It's the same equations either way. So I can just take this Ix prime equation, that's my Ix bar, is going to get me pi 16ths minus 4 over 9 pi times my radius. The radius here was 10 to the fourth. Plus my distance from the x-axis to the centroid of shape 4 squared, or plus, well, my centroid formula here measures 4r over 3 pi from the flat side, so I need to first go up in the y direction to the flat side. So plus 13 plus 10, not 13 plus 10, sorry, 9 plus 10, 9 plus 10, so that I'm starting all the way at the bottom here. And then I come back a little bit. I've gotten to the very top of my object. I'm coming down 4r, 4 times 10 over 3 pi. Back into this, where this is 4.23-ish, 4.24. So 19 minus 4.24, this is about 14.76 that we'll end up using in here. We square that and we multiply by the area. So times pi times the radius, 10 squared, divided by 4, because it's a quarter circle. Or this is going to get us, my final piece that I need is 649.7 inches to the fourth. 4 pieces, I can sum that all up, and I get my answer out here. Ix should be equal to, well, remember, Ix1 and 2, these are both positive ones. Could have even marked that off. This is positive, this is positive, this one's negative, that one's negative, just to help us remember that. We don't have to, though. But Ix1, positive, so 911.25, plus Ix2, 36,780, minus Ix3, minus 7942.34. And then minus our last one, 17,649.7. which summing that all up, I'm going to get here that Ix is 12,099.21 inches to the fourth, which is our very last answer for our problem. Again, slow and steady with these. I found it helps me to write out the parallel axis theorem as I go through that, so I can reference moment of inertia about any axis is my moment of inertia about the centroid plus the distance between these two axes squared times the area of the piece that I'm working with. And I just piece by piece break that down and add it all up. And remember, we might have to adjust some of these equations if an object is flipped on its side or oriented differently in here. Really, it's the semicircles that tends to be the biggest challenge for. We'll go ahead and wrap up there. Hopefully this was a useful video for you. If it was, stick around and watch some more. Help me out, hit those like and subscribe buttons. Let's get you an A with JJ.